Alright, so now we are going to be going through the different notations associated with this chapter on the binomial distribution. Relatively straightforward. You just need to know that there are just two parameters whenever it comes to binomial distribution, right? And the two parameters are the number of n independent trials, so n over here, and also the probability of success, right? So you have your p success, but I'm just going to call it p from now onwards. Okay, so how do we actually say that x follow a binomial distribution? Instead of writing out in words, we will usually write it this way. So x over here, know that this is our discrete random variable, okay, so DRV, follows a binomial distribution, and here we'll write down the number of trials and the probability of success. So this way is usually how we denote that something follows a binomial distribution. Okay, and I'll show you how we actually apply this in the question below. Alright, so feel free to pause this video right now to actually tackle this question if you are feeling confident. Otherwise, I'm going to go through this question right now. Okay, so they say suppose we roll a ordinary die 3 times. Same experiment 3 times, therefore it's n independent trials, right? So 3 independent trials. Let x over here, this is our discrete random variable, and the number of sixes obtained. So this over here is the success condition. So a lot of the things, right, require you to read in between the lines. Okay, so our success condition is 6. And therefore, we know that the probability of a 6, which is our success, is going to be 1 over 6, right? And remember the 3 conditions for binomial distribution, right? 1, 2, 3. We have n independent trials, which is true. We got 3 independent trials, right? Only 2 outcomes, success or failure. So success or failure, which is true because it's either 6 or not 6. Right? And then the probability of success is constant, which is true because the probability of a 6 is always 1 over 6. So we know that therefore x over here is a binomial variable whereby it has 3 trials and the number of success or the probability of success is 1 over 6 in each trial. So recap, here is n, here's p. Okay, so now we want to find out what is the probability of x equals to 2. So for I, p bracket x equals to 2. This is something that you can key in your calculator to actually help you compute, and you actually don't need to use the formula, which is, remember what I taught you earlier, which is equals to n choose x, p x, and then 1 minus p n minus x, right? This over here can be very quickly calculated with using a calculator, and I'm going to show you how we actually do it right now. Alright, so remember our n is 3 and then p is 1 over 6. Okay, so I'm just going to show you the calculator here. Okay, so over here, you just go press second, then here, so DISTR, right? And then from here, you want to go down to binomial PDF. So binomial PDF and binomial CDF, what's the difference? PDF is when you want to calculate the probability of one specific value. So in our case over here, right, is x equals to 2. But then you see for triple I is up until 2, right? So you can have 0, 1, or 2. So PDF is one specific value. CDF, the C stands for cumulative. So C means from 0 up until 2. Okay, so just remember, PDF, one specific value. CDF means a range of values. But in this case, we want one value. So we click this, right? So we press enter. So how many trials do we have? We have 3 trials. Probability of success is 1 over 6. Right? And then what is our x value? So in this case over here, if you recall, our x value is 2, right? So we just got to click 2 here, paste, enter, and then we get this 0.694 dot 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 dot. And then from here, I'm just going to change this to a fraction. I'm just going to go to math, fraction, enter, and then 5 over 72. And therefore the final value over here is 5 over 72. And that's the final answer for I, right? Double I, calculate the probability distribution or tabulate the probability distribution. This is basically just draw the table, right? Remember, probability distribution table. So we're just going to draw the table over here. So double I, we know that x over here, when you roll a die 3 times, right? How many number of sixes can you obtain, basically, right? So remember, always remember what your x represents. So out of 3 times where you roll the dice, you can get 6 how many times? You can get 6 0 times, you can get 6 1 time, you can get 6 2 times, or you can get 6 3 times. And then over here, we write out the probability over here. So earlier on, we computed that this value over here is 5 over 72. So let's just compute the same thing for 0, 1, and 3, right? Using this whole idea over here again. But just a shortcut, right? If you want to just copy, just press, then you go down, you press enter. Then over here, you can just adjust the variables accordingly. So let's say this is 0, then I enter. Then I get this. Then I just go back to math, fraction, enter, right? Then I get 1 125 over 216. So the last value over here is the x value, right? So 125 over 216. So over back to here, I have 125. I'm just going to write in black. So 125 over 256. Then I repeat for 1, right? So I just go back up, scroll back up to here, click enter. I change this x value to 1, enter. I press math. I change this to a fraction. I enter, and I get 25 over 72. So here I get 25 over 72. And then for the last value of 3, you can just take 1 minus all the other values to get the final value, or you can just repeat the same process over here, right? But just to speed things up, I'm just going to write the final answer here is 216. That's the final answer over here. Okay, now for triple I, again, now we want to find the probability of x is smaller than or equals to 2. Now, based off the probability table over here, we know that it's a sum of, it can be 0, or it can be 1, or it can be 2, right? And what you can do is that you can just add up all the individual fractions that you see on the screen over here. But I'm just going to show you how we actually use this on the calculator, right? So this one is a cumulative distribution, right, up until 2. So we will use CDF instead. So I will come back here, press second DISTR. I'll go down to binomial CDF. Then here I have 3 trials. Probability of success is 1 over 6. And then my x value is up until 2. So I just press enter, enter, paste, and I get this in 3SF. So I get a final value over here of 0.995 in 3SF. And that's the final answer to this whole question over here. Okay, so most binomial questions is more or less like that. Go and try it out for yourself. Practice more. Practice makes perfect. Let me know if you've got any other question in the comments below. Otherwise, I'll see you in the next video for the next concept.